Okay, so today we are learning about Newton's third law and momentum. Newton's third law states that for every action force, there is an equal and opposite reaction force. It's called the law of action and reaction. An example of that is sitting in a chair, you exert a force down on the chair, and the chair exerts the same force upwards on you. Also, you can think about it if you exert a force greater than your weight on the ground, it exerts that same force back up on you and it causes you to jump. You could also say that Newton's third law means that all forces act in pairs that are equal in size, opposite in direction. Force pairs do not act on the same object. That's how objects are able to move. Although they're equal and opposite, they do not cancel each other out because they're acting on different objects. For example, a swimmer pushes the water backwards and it has a reaction force of pushing the swimmer forward. So that's kind of how you swim. You push the water backwards and then you go forward. And then today we're also going to talk about momentum. This is the subject we haven't really talked about yet in class. All moving objects have momentum, and momentum is a quantity that equals mass times velocity. And it's also a vector quantity, which means it has magnitude as well as direction. For our class, we will only talk about momentum as being positive or negative rather than give the specifics on the vector. And the P is what stands for momentum, and then M is mass and V is velocity. Force is also related to a change in momentum. The reason why that works is if you have a change in momentum, that means you have a change in velocity. And we all know that a change in velocity means acceleration. And when we have acceleration, what do we have to have along with acceleration? Well, we have to have a force. So a change in momentum has to be caused by a force. The longer the amount of time it takes to change momentum, the smaller amount of force is needed. Simply, that just means the shorter the amount of time, the more acceleration something has, which means a bigger force. An example of this is like the padding on a wall behind a basketball goal. Okay, the padding, it gives you a increase in time on the amount of time it takes you to stop. Whereas if you just run into a concrete wall, the change in momentum is going to happen almost instantaneously, and that's going to yield a bigger force, and that's something that you would feel. Momentum is conserved in collisions. Total momentum before a collision is the same as after a collision. And this applies to cars that bounce off one another or stick together. Cars that bounce off one another is referred to as a elastic collision, and the ones that stick together is inelastic. Also, momentum can be transferred from one object to another. An example, pool balls. A pool ball will transfer all of its momentum to another pool ball. And you can see this because the pool ball that is moving, when it strikes the next pool ball, it stops, and the other pool ball continues along its path at the same velocity as the first pool ball. Okay. We also need to do momentum Koopa practice. So we have here a car has a mass of 1,800 kilograms and is moving at 16 meters per second. What is its momentum? So first we got to find our knowns. So take a look at our knowns. Okay. 1,800 kilograms is a mass measurement. We know that because of the kilograms. And then 16 meters per second is our velocity. Our unknown is momentum. The question obviously states what is its momentum, so that's what we're trying to find. Our equation is momentum equals mass times velocity. And then we go to plug in those numbers, and mass is 1,800 kilograms, and V is 16 meters per second. We multiply those together, and we end up with 28,800 kilogram meters per second. So that's how much momentum the car has. Our next practice problem is we have a soccer player running at 6 meters per second and has a momentum of 330 kilograms times meter per second. What is his mass? So I want you to look at the knowns. And 6 meters per second is velocity. We know that because velocity is measured in meters per second. And then the momentum is 330 kilograms times meters per second. And we know that because of their units as well. Our unknown is, should be mass. I don't know where I have P written in there, so change that to mass. Because the question asks for mass. So we have our equation, P equals M times V. And to solve for M, we have to divide both sides by velocity, and we end up with mass equals momentum divided by velocity. So that would be 330 kilograms times meters per second divided by 6 meters per second. So you just type 330 divided by 6 in your calculator. And those meters per second will cancel out, and we are left with an answer of 55 kilograms. And here's the last one. A 0.3 kilogram baseball has a momentum of 25 kilograms times meters per second. What is the velocity of the ball? M equals 0.3 kilograms and momentum is 25 kilogram times meters per second. Our unknown is velocity, because the question states, what is the velocity of the ball? Our equation, P equals M times V. To solve for velocity, we have to divide both sides by M, and that ends up giving us velocity equals momentum divided by mass. And that's going to be 25 kilograms times meters per second divided by 0.3 kilograms. So in your calculator, you would type 25 divided by 0.3, and then our kilograms would cancel, leaving us with 83 meters per second. Okay, so now you're going to have some of these problems to do on your own.